Welcome to the deep dive. Here, we take your sources, peel them back, and really pull out the key insights just for you. Today, we're plunging into, well, the pretty fascinating world of NetApp ONTAP features, but we've got a bit of a unique angle. We're going to explore these really powerful capabilities by looking at specific, kind of real-world scenarios. Think situations like you might find in, say, the NS0-528 exam practice questions. Now, our mission today isn't really just about getting the right answers. It's bigger than that. We want to extract the really important stuff, the insights from these situations, giving you a shortcut to being, genuinely well informed about these critical data management concepts. Think of it like getting a backstage pass to see what really makes enterprise storage work.
And you're right. While these scenarios, yeah, they often look like an exam structure, maybe 60 questions, multiple choice, multiple select, 90 minutes, that kind of thing, their value goes way beyond just passing a test, much broader. So whether you're prepping for a big meeting or just trying to get up to speed on enterprise storage solutions, or maybe you're just curious about how big organizations actually protect and manage all that data, these questions really light up the crucial principles. We're talking about the foundations: high availability, really solid compliance, smooth data migration, and fast, dependable recovery. These aren't just tech specs. They're the strategies that keep modern businesses ticking, thriving, really.
Okay, then, let's unpack this. Get ready for hopefully some surprising facts and maybe a few aha moments that'll make these technical ideas really click. You'll see how these features connect and how vital they are out there. Okay, let's dive into our first scenario. Right. Imagine you've got this absolutely critical application, something that just cannot go down, ever, not for a second. It needs what they call a zero recovery point objective, or RPO. That means absolutely zero data loss tolerance, none. And you also need the ability for a super fast failover, a really, really small recovery time objective, RTO. So the question is, which NetApp ONTAP solution is hands down the best choice for demands like that? So stringent.
Well, the key insight here, when you see requirements that extreme zero RPO and a tiny RTO, it immediately points towards solutions that don't just copy data. They have to guarantee completely nonstop operation, even if that means spanning across different physical sites. For this scenario, Metro Cluster is the definitive answer. No question.
Metro Cluster. Okay. That's a huge promise, though, isn't it? Guaranteeing zero RPO and that ultra-low RTO. What's the fundamental design? How does it actually deliver on that so reliably?
Yeah, it achieves that peak of data protection by using synchronous mirroring. But it does this across two geographically separate sites. So this means every single write operation, every piece of data you write, is instantly, at the same moment, committed at both locations.
Oh, okay. Instantly.
Instantly. There's no delay, no window where data might only be at one place. So if one site suddenly, fails completely, the other site already has an identical, completely up to the second copy of everything, all your data.
Okay.
And crucially, it's designed specifically for these mission-critical, always-on applications. It provides automatic site failover.
Automatic, that's the key part for the RTO then.
Exactly. That automatic aspect is absolutely key for getting the smallest possible RTO. It minimizes downtime without needing anyone to jump in and do anything manually. Now, you might think of SnapMirror Synchronous that also gives you zero RPO. But Metro Cluster's specific architecture for fully automatic failover and just the highest level of availability, that's what really makes it stand out for these top-tier needs. It's not just replication, it's guaranteed continuous operation, nonstop.
Right. So the real value isn't just having the data copied, it's the automatic switchover and knowing it's instantly accessible if disaster strikes. That really explains why Metro Cluster is so critical for those vital workloads. Okay, moving on. Our next scenario deals with something equally critical, especially today, compliance and data integrity. So an organization is facing really strict compliance rules. They have to ensure certain data absolutely cannot be changed or deleted for a specific fixed period. We're not just talking backups here. This is about immutable, tamper-proof storage. Which ONTAP feature gives you this write once, read many, or worm capability?
Okay, yeah. When an organization really needs to legally lock down data against any changes, to ensure complete trust in records for compliance, for audits, SnapLock is the one. It's the feature specifically designed for exactly that.
SnapLock. Got it. So that's the key for worm. I can almost hear compliance officers breathing easier knowing data's truly locked. But how does it actually ensure that data stays genuinely, untouchable for those required times?
Absolutely. SnapLock essentially turns standard ONTAP volumes into worm-compliant storage. Once data is written to a SnapBlock volume, it becomes, for all intents and purposes, immutable. Can't be modified, can't be deleted, not until its preset retention period officially ends.
And this is absolutely critical in certain industries. Think financial services, healthcare, places where data integrity for audit trails or legal records or patient info is just non-negotiable.
Okay.
You can think of it like a digital time capsule, basically. You just can't open it or change what's inside before its time is up. Other features, like Snap Mirror or Snap Vault, great for replication, great for backup, but they don't give you this unchangeable worm compliance that SnapBlock delivers. It's a very specific tool, but incredibly powerful for this very high-stakes problem of, well, trust and legality.
It's amazing, really, how a feature like SnapBlock underpins so much of the trust we put in digital records. It's not just a technical detail, it's fundamental. Legal, ethical, data management. Okay, now let's switch gears. Let's talk about moving data. Migrations can be a massive headache, right? Especially when you're dealing with different kinds of systems. So let's say you need to migrate a LUN, that's a logical unit number, from a third-party storage system, so not another NetApp system. You need to move it to a brand new ONNTAP cluster. Which ONNTAP feature is specifically built for this kind of unique data import, especially if you want to minimize disruption?
Right. If you think about the big picture, IT infrastructure is always evolving. Data migration is constant. And moving from a foreign system, a third-party system, brings its own set of challenges.
Yeah.
The core insight here is finding a solution that lets you migrate smoothly, non-disruptively, from pretty much any vendor. For this specific case, foreign LUN import, or FLI, is the crucial capability. That's the one.
Foreign LUN import, FLI. Okay, sounds pretty descriptive. But what makes it so different from other migration tools, especially coming from non-NetApp gear? You mentioned non-disruptive for the host system. That's huge for IT teams, right? Because migrations are often notoriously disruptive. How does FLI manage that?
Yeah, that's really where FLI shines. It's specifically engineered to migrate LUNs from those third-party arrays directly into an ONTAP cluster seamlessly. The real genius, you could say, is that it does this without needing any changes on the host side, the server using the LUN.
Ah, okay. No host changes.
None. So the applications using that LUN, they don't need reconfiguration. They don't experience an outage. They aren't disrupted while the migration's happening. It essentially allows for a direct block-by-block copy of the data into the new ONTAP cluster while the original LUN stays online and accessible the whole time.
The whole time.
The whole transition, this massively cuts down time and risk, saves countless hours, major headaches for IT teams. Compare that to tools like, say, SnapMirror or BlueXP Copy and Sync. They're mainly built for transfers between NetApp systems, or maybe NetApp to cloud. FLI fills that very specific, very important gap, pulling data directly and non-disruptively from other vendors' LUNs.
That difference is critical. Knowing you can do a major storage migration without messing with host configs or apps, that's really empowering for IT folks.
Definitely. Okay, let's switch gears again. Another common and sometimes, panic-inducing situation, accidentally deleting a file. So an administrator, maybe it's late on a Friday, accidentally deletes an important file from a production volume. Luckily, they've checked, and snapshot copies do exist on that volume. Phew. What's the absolute most space-efficient and fastest way to get that single file back? Yeah, that's a scenario everyone in IT kind of dreads, right? But it's also where the elegance of NetApp's snapshot tech really comes through. The key insight here is just how precise and efficient snapshots are for this kind of targeted recovery. So the most efficient method, the quickest one, and therefore the right answer, is simply to mount the snapshot copy directly and copy the file back, just like that.
That sounds remarkably simple, almost too simple compared to what some might think data recovery involves. Can you elaborate a bit? Why is that direct access to a snapshot copy so effective and space efficient instead of, say, restoring the whole volume?
Absolutely. What's really interesting here is how snapshot copies actually work. They aren't full, separate copies of all your data taking up tons of space. Not at all. Instead, a NetApp snapshot is a highly efficient point-in-time image of your volume's file system. It's essentially just a set of pointers to the original data blocks.
Ah, just pointers.
Right. So when a file gets deleted accidentally, the actual data blocks it used, they're still preserved within that snapshot. They haven't gone anywhere. So by mounting or just browsing the hidden.snapshot directory, every volume has one, the admin can navigate into that specific snapshot. Find the deleted file sitting right there and simply copy it back to the live active volume.
Just copy-paste, essentially.
Pretty much. This whole approach completely avoids restoring the entire volume. That would take way more time, and you might overwrite newer changes you want to keep. It also means you don't need to create a full clone of the volume which would mean allocating the same amount of storage space again. It's surgical, it's
Yeah,
precise, and it's incredibly light on resources. It really is like having a digital time machine just for individual files.
that's powerful. A digital time machine for files, but one that doesn't need extra power or storage for every trip back. Excellent. Okay, finally, let's talk troubleshooting. Even with the best systems, network problems pop up, and you need the right tool for that specific job. Let's say a snap mirror relationship, which is critical for replicating data, has unexpectedly broken between two clusters. The administrator thinks maybe a firewall is blocking the connection between them. A common issue. So, on the source cluster, they need to test connectivity to the destination's intercluster LIF, that's its network interface, but on a very specific network port N1000. Which tool is the most appropriate for this very specific check?
Okay, this brings up a really important point about basic network diagnostics, especially when you're dealing with specific application ports. The core insight here is that for precise port-specific connection testing, you need a utility that can actually try to make a connection to that specific port. In this scenario, the correct tool, the best one to use, is Telnet.
Telnet. Okay. Some might think that's a bit old school, right? I know a lot of IT pros might immediately think of Netcat or maybe worry about Telnet not being encrypted, especially in production. So for this specific task, just checking the port, why is Telnet still the go-to, even with those points in mind?
That's a great point, actually, and it really highlights why picking the right tool for the specific job is so important. While Telnet, yeah, definitely not recommended for secure admin access. It sends everything in clear text, no encryption, bad idea for logins. But it remains a very simple, very effective diagnostic tool for one crucial task, checking if a specific TCP port is open and reachable on a remote machine.
Just that one task.
Just that. You can specify both the target IP address or its host name and the port number, like you said, Telnet destination of 1000. If Telnet connects successfully, even if it just shows a blank screen or some banner, you instantly know the network path is open. And critically, you know that no firewall or network security rule is blocking traffic on that specific port. That's the key. If it fails, hangs, or gives a connection refused, you found your problem. A blockage right at that port. Now, ping, useful, sure, but it only checks basic network reachability using ICMP. Doesn't tell you anything about whether a specific port like 10,000 is open. Netstat shows you network connections on your local machine. Kulnish is for secure logins. Neither of those is designed to test if a specific port is open on a remote host in this way. It really comes down to precision and troubleshooting, and Telnet gives you that direct port-level check you need here.
That's a fantastic distinction, yeah. It's not just about reaching the server, it's making sure the specific door you need to use, port 10,000 in this case, is actually open. Knowing when Telnet is the right tool for those port checks, that's a really vital piece of knowledge for anyone managing these complex network systems.
If you consider these fundamental concepts like ensuring zero data loss, even across different locations, or making data truly unchangeable for legal and compliance reasons, or enabling smooth, non-disruptive migrations from all sorts of different systems, how will these core ideas continue to shape the way we build and protect our most critical digital assets? Especially as technology keeps evolving so fast, what sort of new challenges are going to pop up that demand even more refined versions of these principles? And how might these foundational ideas themselves have to adapt to meet whatever comes next?
Those are powerful questions for all of us to think about. We really hope this deep dive has given you some valuable insights, maybe a few of those aha moments we talked about. Thank you so much for joining us today, and we look forward to having you back for our next deep dive into the fascinating world of knowledge. Until then, keep learning.